So this is National 4 Chemistry, Unit 1, and today's topic is going to be about naming compounds and writing chemical formula. So the first thing we need to think about is the names of compounds. Now remember, a compound is formed when two elements react with one another. And each compound's name has two parts, which tell you the two elements that it's made out of. So for example, sodium chloride, two parts. Each part tells you one of the elements inside it. Iron oxide, each part tells you one of the elements inside it. So sodium chloride. Well, the sodium part tells you that there is sodium inside it. The second part of the name, ignore the ending IDE and just look at the first part of that word. We see that it is chlor, and all you need to do is look for an element that starts with the same few letters, and that element is going to be chlorine. With iron oxide, well, the iron tells you that there's iron in it. Oxide, ignore the letters IDE and just look for an element that starts with the same letters as that word starts with. So ox, the only element that starts with ox is oxygen. So iron oxide contains iron and oxygen. The IDE ending, what that's there is just to tell you that there are only two elements in the compound. Now, in order for us to write chemical formula, there's something we need to know about each element, and that's a thing called valency. Now, valency is used to write chemical formula, and each group in the periodic table has a different valency. Now, you are just expected to remember these valencies. They are not in your data booklet. However, if you have a copy of data booklet at home, I suggest that you write these numbers on from this slide. And this is page 6 of the data booklet that we're looking at. So page 6 shows the different groups that you could be asked to either name a compound from or write a chemical formula from. So it's going to be groups 1 to 8 or groups 1 to 7, and group 8 is sometimes called group 0. The numbers that are going to show at the top of that picture on the right are the valencies. So group 1 has a valency of 1, group 2 has a valency of 2, group 3 a valency of 3, and group 4 a valency of 4. That's very easy. But after that, we've got to remember that once we get to group 4, the numbers start counting back down. So group 5 has a valency of 3, group 6 has a valency of 2, group 7 has a valency of 1, and group 8 or group 0 has a valency of 0. Now if you remember, noble gases are those ones in group 0. They don't form any bonds, so they don't form compounds, and if you don't form a compound, you don't need a valency, which is why they have a valency of 0. But the other ones, remember that it goes 1, 2, 3, 4, 3, 2, 1. And I suggest you write that on your copy of the data booklet on page 6. So now we need to think about how to write a formula. And you're going to follow a 5-step process. The first thing is, from the name, work out the elements and write down the symbols for each of those elements. Then, under the symbols, you're going to find out what the valency is for each element. And now that we've written the valencies on our data booklet on page 6, we'll be able to work out what the valency is. We then swap the valencies over. So whatever valency your first element had, you're going to swap that to your second element. Whatever valency your second element had, you're going to swap and give that to your first element. Now step 4 is one that's not often needed, but it is divide. So it's look at the valencies and look at the ratio. If that ratio can be simplified, you're going to divide the numbers to make it the smallest numbers possible. And finally, whatever numbers we have for each element will allow us to write the formula. Now it sounds more complicated when it's spoken about than when you see it done in practice. So I've got 2 different examples to talk you through. So the first one is sodium chloride. Now sodium chloride, we know from the name it contains sodium And the chloride, well, if we ignore the letters I, D, A and just look at chlor, the element that starts with the same letters is chlorine. So this contains sodium and chlorine. Then we can look up our data booklet to find out what the symbols are. Now, sodium is Na and chlorine is Cl. Now, with the valencies, look at these elements on page 6, and you can find out that sodium is in group 1, so it has a valency of 1. Chlorine is in group 7, and it also has a valency of 1. Now, we swap these numbers over, and nothing really changes. It's still 1 under sodium, 1 under chlorine. We have to ask ourselves, can we divide these numbers to make them smaller? And the answer is no. So we're just going to write the same numbers again. And now we can write our formula. There is 1 sodium atom. So all we need to do if there is 1 of an element is write Na. Chlorine, if there's only 1 of it, then we just write Cl. If there was 2 sodiums, we would write Na2Cl. If there was 2 chlorines, we would write NaCl2. And the number, if it's not 1, goes in the bottom right-hand corner. Our next example is magnesium sulfide. So magnesium sulfide, we have to look up the elements inside it. Now magnesium tells us there's magnesium in there. Sulfide, ignore the IDA and it's sulf. Look for an element that starts with the same letters, and that's going to be sulfur. The symbol for magnesium is Mg. The symbol for sulfur is S. From page 6, magnesium is in group 2, so it has a valency of 2. Sulfur is in group 6, so it has a valency of 2 as well. When we swap these numbers, again, nothing interesting happens. There's still a 2 under magnesium, a 2 under sulfur. But now when we ask ourselves, can we divide to make these smaller? Our answer is yes. 2 and 2, we can divide each of those numbers by 2 to give us 1 and 1. So when it comes to writing the formula, it's going to be just like before. MgS. There's 1 magnesium and there's 1 sulfur. So one final example is sodium oxide. Now from the name, we know it's going to contain sodium and oxygen. The symbols are Na and O. Sodium is in group 1, so it has a valency of 1. Oxygen is in group 6, so you need to remember that that means it has a valency of 2. When we swap these numbers, we now end up with a 2 under sodium and a 1 under oxygen. Have to ask ourselves again, can we divide these numbers to make them smaller? The answer is no. So we end up with 2 still under sodium and 1 still under oxygen. So when it comes to writing the formula, it's going to be Na with a 2. Remember that 2 needs to be small and to the right-hand side. And just 1 oxygen, so we just need to write the symbol Na2O. Now, some chemicals don't require you to use that method. And examples are things like carbon dioxide or aluminium trichloride. The di part of carbon dioxide tells you that there are 2 oxygens. Di means 2, dioxide, 2 oxygens. Aluminium trichloride, tri means 3, like a triangle. And so there are 3 chlorines. Now these names have those clue words, the bits that I have highlighted in red, that tell you how many there are of a particular element. Now the clues that you need to remember are all the way from 1 up to 6. Now mono means 1. However, say if there's a clue word for one element and the other one doesn't have a clue, not having a clue would also mean 1. Di means 2, tri means 3, tetra means 4, penta means 5, hexa means 6. So we're going to see how to use these. So if a compound contains any of those clue words in the name, you can work out the formula without using the valency. So if an element contains a clue, like di, tri, tetra, that clue tells you how many there are of that element. Now the clue comes before the name of the element, but the number has to be written small and to the right of that element. If an element doesn't have a clue attached to it, then there's only one of that element. So for example, in carbon dioxide, the di part was a clue for oxygen telling you that there were 2 oxygens, but carbon didn't have a clue, which meant there was only 1 carbon. So that's been the rules for how to work out a formula using the SVSDF method, and also some formula where you do not need to use that method because the name gives you clues. What I've got now are 4 questions that I would like you to practice. Sodium fluoride, magnesium sulfide, phosphorus trichloride, and carbon tetrabromide. Have a go at those. The next slide has all the answers. So pause the video, have a go. Hopefully you've paused the video and you can see that the answers for sodium fluoride should have been NaF. Magnesium sulfide, MgS. Those two required you to use SVSDF. Phosphorus trichloride, well, that had a clue for chlorine. So it was P, only 1 phosphorus because there was no clue for it. Trichloride, Cl3. Carbon tetrabromide, well, that has a clue word in it. Tetrabromide means 4 bromines. Carbon didn't have a clue, so there was only 1 of it. So overall, CBr4. Hopefully that's cleared up how the names of compounds are created and how we can use the name of a compound to work out its chemical formula.